Okay, so this problem is from the Chapter 1 homework set, and it's on dimensional analysis. And by dimensional analysis, all we mean is that we're checking to make sure that the simplified unit on the left side of an equation is the same as the simplified unit on the right side of the equation. That's all we're doing. We're checking the units. So the equation we're given is right here. T equals 2 pi square root L over G. Okay, capital T is the symbol that, and this is a real equation. I'm just going to spoil the ending for you. This equation is dimensionally correct because it is a real equation. When you take the AP test in May, you're going to have this equation in your brain. What this equation is it's the equation for calculating the period of a pendulum. Now, what is period? Because you're going to need to know what period is. Period is the time for one cycle. Now, what's a cycle? Well, there's biological cycles, the period. Once a month, Spaldo gets in trouble. But in physics, there's 4 periods that you're going to have to be familiar with. Okay, so there's pendulums. Pendulums have a period. What do we mean by the period of a pendulum? The time for one complete swing, one complete there and back, one complete cycle. What else has a period in physics? Mass on a spring. So imagine a spring hanging from the ceiling, and we hang a mass on it and let it go. Well, that mass on the spring would go doing, 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 doing. It would start bouncing up and down, right? The period for mass on a spring is the time for one complete doing, doing. Okay? What else has a period? Circular motion. Things in a circular path. It could be a car going around a circular, like a roundabout in a road. Anything in a circular path has a period. And so what do we mean by the period for an object in a circular path? The time for one complete revolution, one complete circle. And then the last thing that has a period in physics are waves. We could talk about the period of a wave, which would simply be the time for one complete wave. Imagine like waves. Imagine like you're sitting out in the ocean and waves are rolling underneath you, like a boat goes by, and you feel yourself bobbing up and down. The time it takes for one complete wave to pass underneath you would be the period of the wave. So period is the time for a cycle. And you know what? You can go home and verify that this equation is true. Capital T is the period. So what's the unit for period? Well, minutes would work. Hours could work, but capital T is period, which is time. In physics, we always want to be in units of second. So capital T is going to be in seconds. L is the length of the pendulum. So what's that going to be in? In physics, what do we measure length in? Meters. Length will be in meter. Now, gravity, we're going to talk about later in Chapter 2. We'll get to that tomorrow. Gravity, you could either say that gravity is a force, or you could talk about gravity as being an acceleration, right? Like if I take this hammer and I drop it on somebody's head, which I won't do because I want to keep my job. If I take this hammer and I let it go, what would this hammer do? Fall. Yeah, it would fall, but what's the word? It would accelerate. So you all have an idea of what acceleration is. An object accelerates when it's going faster, 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 or slower, slower, slower. Does gravity cause objects to accelerate? Definitely. You step off a diving board, you're going to accelerate downward. Okay? So gravity is an acceleration. The unit for acceleration, does anybody know the unit that we measure acceleration in? Meters per second squared, which we'll talk about tomorrow, because right now I'd say like 80 or 90% of you are like, what the heck, man? Because like what is second squared? How do you square a second? Yo,
Well, it's how meters per second will be how fast it is, and meters per second, how much is that speed?
exactly. Yep, well, you just said it. Meter per second squared, and we'll talk about this tomorrow, but really the way to think about it is meter per second. That's where because this simplifies to give meter per second squared. Okay? All right, so let's check this equation. So the equation is period equals 2 pi square root L over G. Do we care about the 2 pi here? No, because what are we checking? Only the unit, so forget about that 2 pi. All we're doing is we're checking to make sure the simplified unit on the left side of the equation matches the simplified unit on the right side of the equation. Okay, so period gets measured in seconds, and then we get square root. Now what's length? Meters. I'm just plugging the units in. Length is meter, and then what's gravity? Meters per second squared. Now, what happens to these meters? They cancel. So here's where your algebra skills have to be pretty decent, So meters cancel, and then what we're left with is the square root of 1 over second squared, which is the same as square root of second squared, right? This right here, 1 over second squared, is the same as second squared. And then what's the square root of second squared? Seconds. So is this equation dimensionally correct? Yes. The simplified unit on the left is seconds. The simplified unit on the right is second. So that's all we mean by dimensional analysis. Any questions on this?